information and storage and processing issues. And then we have cloud computing, which is a promising technology that's supposed to help us to handle the issue of big data, and it also in the configuration and manipulation of data and run the application. And data center where we can implement this cloud computing and provide storage and computing services to the user. These are the most popular actually cloud computing resources or data centers that we have, which is my motivation. If we can help them to decrease their size, of course it can provide better experience also to their user. And here we see like there are three main challenges that they mainly face in the geo-distributed data center, which are computing and storage and communication, that would lead to a massive operation expenditure. That's why but then there are some, and there are a lot of researchers have done about this, how to decrease like the storage, how have faster communication and everything. But there are some factors that we neglect, and one of them is quality of service, and another one is storage cost. And the scope of this project is mainly in the service side, and here I just consider 4 parameters: task assignment, data placement, data storage, and quality of service, and for the cost only communication and service cost. And here we have a table of comparison that I analyzed few of papers, and I divided them in 4 categories. One of them being data processing. This is a paper I also use for my simulation. I use these colleagues' formulas to do the simulation and comparison. And as you can see, for her she used 3 parameters: task assignment, data placement, data storage, and quality of service, and she achieved actually a good result. For example, she has a low delay, and also the energy was minimized, but then she still didn't consider the storage cost and some other factor like IDS. And then the other category we can have data center management, that in most of them they just consider maybe few data related to the data center management. They will neglect the parameter related to the big data. Like here they just, in the first paper it start, even though they have really, they got a really good result, 42% of cooling energy cost reduction, still they didn't consider a lot of parameters. Like for example, they didn't consider like multiple virtual machine resources, like for example CPU, memory, and things like that would face a lot of problem if you really want to implement this technology in the data center. Or other one, you will see that they could improve the dynamic resource collection, but still they have some issues. And the same thing goes to the other category, which is the data placement. Here you see they could minimize the number of reassignments, but still didn't consider the complexity, and that's why it's not really practical. And the last category that I have here is the electricity management. And also in this case, they just consider the parameters related to electricity more than, like for example, the managing the data center management, etc. And these are the formula I used for the simulation, which is the MIDP. Actually, I think some part is it's mixed integer linear programming, and that's why I have a formula for the cost that considers the communication cost and the server cost, and based on some subjective to data placement, task placement, data loading, and quality of service. If you want more detail, you can refer to this address where I got the formula actually from this paper. And also after that, she linearized the formula, which really helped for the calculation, and also the quality of service. So actually, if we can have an optimal solution for this problem. This is where it should be placed. Between front portal and data center. Before sending directly the information that we got from the user to the data center, we can implement this technology that we can achieve, and then later we decide to which data center send it so we can have lesser cost and better performance. And these are some of the results that I got by comparing joint optimization and non-joint optimization. For example, in this case, in the joint optimization, I consider four factors: quality of service, task assignment, task management, and other one for that. But then here, that you can see that one is, the blue line is for the joint, and the other one is, for this one, I just consider task assignment. And as you can see, as the data chunk size increase, which of course the communication and server cost will increase, but we could get better results when we had a joint optimization. And also I compare a joint optimization with another single factor, which in here is data placement. And you see when the number of servers increase, it kind of helped in both of them to reduce the communication and cost factor. But in most of them, after a while, it's like constant and it's not really helping. But still, we would get better results if we use the joint optimization method. Actually, this here what we can conclude is if we can consider more parameters, we can have lesser cost for the data centers and also more realistic result. And also that we see that most of the methods that are used nowadays, they just consider few factors and neglect the others. That's why they couldn't achieve the ideal formula for the cost minimization. And some of them also neglect the complexity of their formula. And for example, the one that we had in the 6, that's why it's better if they can overlook the issue and by like implementation complexity. And these are the references. So thank you. Any question?
Sir. I leave the venue to you, not only.
Sir, we are waiting for you, sir.
No, Sesha likes this one.
They have the question.
Okay, so thank you very much.